Determine whether the data values are categorical or numerical. In my class, we refer to these as qualitative or quantitative. So the types of favorite snacks of 38 coworkers, the snacks are going to be described with a label. So we're using qualitative data. If the data is described using numbers, then we would use quantitative data. So labels or numbers. What is the typical number of movies that a student in our class watched last month? This is a statistical question because we can answer the question by collecting data on the number of movies that different students watched last month. And their responses can vary. Some people might watch more movies, and some people might watch less. We would collect data. We could create a different display, whether that's a histogram, a dot plot, or so on. And then we would find the typical value of that data distribution. Some different ways that we find the typical amount is the mean or the median. The way that we collect data is based on the people or the population in our question. So here it's just students in our class. But if we change that to be students in our state, we would need to look at a different data set or a different collection of people to survey when we're collecting data. For each statistical question, indicate whether you would collect data from the whole group or part of the group to answer the question. Then explain how you could collect the data. So here, what is the largest number of pairs of shoes owned by a student in my class? Well, we could collect the data from the whole group. And then we need to explain how we would collect the data. We can ask everyone in our class to write down how many pairs of shoes they own. How much does the price of a home in your town vary? Well, collecting data on every house in our town might be a little more complicated than just asking all of the people in our classroom. So in this case, we would collect data from the part of the group. And we could search online to find the prices of homes listed for sale in our town. C. What is the typical number of pets owned by people in your neighborhood? You could collect information on all of the people in your neighborhood. We could walk around and talk to our neighbors and ask them how many pets they own. What is the typical number of absences in math classes at your school on a given day? We could collect data from the whole group here. We only have one math teacher at our school, and we would have data from the classes that they teach. You also have math teachers at schools, but they take attendance, so that information is already gathered every day. So we could collect the whole group's data. How long does a flashlight battery from a particular brand typically last? Well, we're not going to collect data on every single battery from that brand, so we would use part of the group here. We could buy a pack of batteries and test each one in the pack. But it wouldn't be possible to buy every single battery from that brand and test them all. So we would need to use part of the group. What percent of students in your school have a curfew? We could collect information from part of our school. We could ask students in your classes or several students from each grade level. What is the most common hair color for students in your class? There aren't too many people in our classes, so we could use data from the whole group. And we could observe and record the hair color. For problems 2 and 3, fill in the blanks with the terms that correctly complete the definition. A blank is an entire collection of people, animals, or objects that someone is interested in learning about. Each person, animal, or object in the population is called a member. When you use the entire collection, you are using a population. A blank is a collection of members of a population. That is a sample. So this would be the whole group scenario. And this would be when you look at just the part of a group. A sample out of the population or the entire population. For problems 4 and 5, state whether Logan collected data from a sample or a population. 4. Logan wonders what the typical number of board games my classmates played last month. He asked the students in his class how many board games they played last month. Logan calculates that his classmates typically played 2 games. He asked the students in his class, which includes the entire class. That is a population of data that he collected. Number 5. Logan wonders what is the typical number of board games 7th graders in my state played last month. He asked students in one class in each county in his state, but he doesn't ask all of the 7th graders in the entire state. So this would be a sample. He only asks a few people from one class in each county in the state, not every 7th grader in the entire state. A sample of the data. For problems 6 and 7, fill in the blanks with the terms that correctly complete the definitions. A blank is a numerical summary value that is calculated by using the data from the entire population. This is called a population characteristic. A blank is a numerical summary value that is calculated by using data from a sample. This one is called a sample statistic. So if we're using data from the entire population, it's a population characteristic. If we're using data from the sample, it is called a sample statistic. For these next few problems, we'll do a whiteboard exchange in class. We're just going to go through each of these and determine whether it's a population characteristic or a sample statistic. The first one says, do adults living in the United States approve of the president's job performance? A group of 1,000 adults was surveyed, and 43% of the responders indicated that they approved. Since it's only 1,000 adults out of the entire U.S., this is a sample statistic. The next one, were students in the Bay Shore School District proficient on the national assessment in mathematics in 2019? All Bay Shore students took the national mathematical assessment in 2019, and over 52% of those students were at or above proficient on the national assessment. Since all of the students at this location took the exam, this is a population characteristic. Do drivers who talk on their phone have slower reaction times? Researchers measured the reaction times of 38 drivers as they talked on their phone. Drivers' reaction times were 24% slower when they were talking on their phone. This is only 38 drivers. We're talking about all drivers. They only sampled a few, so this is a sample statistic. What percent of New York State population was over the age of 65 in 2010? Data were collected from all New York residents in 2010 by the United States Census Bureau. The percent of the total population of New York State in 2010 that was over 65 was 13.5%. This says, all New York residents. Data was collected from all the residents. So this is a population characteristic. For problems 8 and 9, we're going to read through some history on the census, and you'll write down 3 things that you find interesting about the census. And then in number 9, why the census is important for the United States. I'll pull up that history page now. You can pause your screen and read through the history of the U.S. Census, and when you're ready, respond to the questions in your workbook. The U.S. used the following New York State data from the 2010 U.S. Census for problems 10 through 12. The population was 19,378,102. For people under 5 years old, there are 1,155,822. There are 15 2,053,173 people that are 18 years old and older, and there are 2,617,943 people who are 65 years old and older. Number 10 says, what percent of people living in New York State in 2010 were at least 18 years old? Round your answer to the nearest percent. So 18 and older and 65 years and older. This set of data here includes the 65 years old and older as well, because it's anybody older than 18, and so the 65-year-olds count in that category. So for this one, to find the percent, we have 15,053,173 out of the entire population, which was 19,378,102. To turn that into the percent, we can use that cross multiply and divide strategy, which comes out to 77.68, but it asks us to round to the nearest percent, which would be about 78%. What percent of people living in New York were 65 years or at least 65 years old? So that is 2,617,943 out of the entire population. Go ahead and cross multiply and divide here. 2,617,943 times 100 divided by 19,378,102 is about 13.5%, but it asks us to round to the nearest percent, so that rounds up to 14%. Are your answers to problems 10 and 11 population characteristics or sample statistics? Explain. These are population characteristics because the data is from the entire population of New York. The American Community Survey takes samples from a small percentage of U.S. population in years between the census. What is the difference between the information collected by the ACS and the information collected by the U.S. Census? Well, the ACS uses samples, whereas the census uses a population. In 2018, the ACS asked a sample of U.S. workers ages 16 and older about their commuting times to work. In this sample, 9.5% reported commuting more than an hour to work each day. Is 9.5% a sample statistic or population characteristic? That is a sample statistic because they sampled some of the workers. Do you think people use the ACS data to learn about the workers in the sample or the population of the country? Well, even though we used a sample statistic, we're using that information to help us generalize patterns or trends that would apply to the entire country. How do you think people use the ACS data? Well, if we were collecting data on commuting times, they might use that data to help them with traffic control, maybe building new roads, putting in stoplights. So we use that data to make plans. D, if there were 146,357,588 commuting workers in the entire population, about how many traveled more than an hour to work each day? So that is the entire population. And the percentage that we had that commuted more than an hour each day was 9.5. So if we cross multiply and divide, that would give us an estimation of how many people commute for more than an hour to work each day. And that is about 13,903,970.8, but we wouldn't want 0.8 of a person, so we're going to round up to 971. In 2018, the ACS asked a sample of households in the United States about the languages spoken at home. In this sample, 21.5% of households reported that English was not the only language spoken at home. Is 21.5% a sample statistic or a population characteristic? Explain. This is a sample statistic because it's based on a sample. Do you think people use the ACS data to learn about the households in the sample or the population in the country? They're using this, again, to make a generalization about the entire country. How do you think people could use this ACS data? There could be programs created to learn other languages. It could also help people determine if they needed to create signs or posters or advertisements in other languages as well. D, if there were 119,730,120 households in the entire population, about how many households spoke one or more languages besides English at home. So there's 21.5%. Percents are out of 100. And our population here is 119,730,128. So we can cross multiply and divide. We're going to round to the nearest whole number because we're talking about people. So we don't want any decimal people. And that is 25,741,978. There's a 0.5, so it rounds that last number up. That is the end of lesson 11. More Module 6 videos will be posted in the playlist.